Hello students, how are you? Hope you are doing very fine in your studies. So today I bring to you a very important topic in physical chemistry, and which is strength and concentration of solution. So this is very important topic in some basic concept of chemistry, and it is also very important topic in solution chapter. So this topic comes in class 11 and class 12 also, and this topic is very important for boards and various competitive exams. So watch the video very carefully and note down. Okay, so let's start. At first, always remember a solution is represented always in terms of solute. A solution is always represented by the amount of solute present in it, not by solvent. So the strength and concentration of solution can be represented in two ways: in percent concentration and in concentration terms. So we will learn first about the percent concentration. So very first, which we will call percentage by weight or by mass. That means percentage W by W. What does that mean? It means the amount of solute in gram present in 100 gram of solution. That means, see, if it is labeled as 30% W by W H2SO4, let's consider this, or 30% by weight or by mass. So what does that mean? It means in 100 gram solution, there is 30 gram H2SO4 present or dissolved. So got it? The amount of solute in grams present in 100 gram solution, which will be represented by percent by weight or by mass or percentage W by W. Another is percent by volume, or it can be written as percentage V by V. What does that mean? It means the volume of solute present in 100 ml solution. So it is mainly applicable for liquid mixture. As for example, let's take an example. It is written as 20% V by V ethanol. So what does that mean? It means in 100 ml solution, there is 20 ml ethanol present as a solute. So if it is written as aqueous solution, 20% V by V ethanol in aqueous solution, if we take this aqueous solution, so in 100 ml solution there is 20 ml ethanol, there is the rest 80 ml is water. Okay, so it is mainly applicable for liquid mixture. Number 3, percentage weight by volume, or it is also called as mass by volume percentage. So it is written as percentage W by V. That means, what does that mean? It means the amount of solute in grams, solute will be in grams, the volume of the solution will be 100 ml. That means the amount of solute in grams present in 100 ml solution. So let's take an example. So let's say it is written 35% W by V NaOH. So what does that mean? It means W by V means solute will be in gram, the volume of the solution will be 100 ml. So 35 gram NaOH, this is solute, is present or dissolved in 100 ml solution. Got it? And the next is percentage volume by weight, which is reverse of the previous. So it will be written as percentage V by W, or it is called as volume percentage by weight. So what does that mean? Let's take an example. So it is written as 25% V by W ethanol. So when the solute is liquid, so what does that mean? It means in 100 gram solution, 100 gram solution, there is 25 ml of ethanol present as a solute. So we learn the percent concentration by these four terms. So by these four terms, a solution can be represented in percent concentration. Okay, so let's move forward to the concentration term, various, which is more important. Now we come to the concentration terms, and very fast it is molarity, and this is represented by capital M. So what is molarity? Molarity means the number of moles of solute. Molarity equals to number of moles of solute divided by volume of the solution in liters. Volume of solution in liters. That means it has a unit of mole per liter, typical unit of concentration. Or it can be written as weight of solute or mass of solute in gram divided by molecular weight or molecular mass of solute multiplied by 1000 divided by volume of solution in milliliter. Volume of solution in milliliter. Got it? So this will be molarity. That means, let me give an example. Just say it is written as 25% H2SO4, 25% W by V H2SO4, or weight by volume percentage. What does that mean? That means 100 ml solution we have already learned in the previous. That means in 100 ml solution there is 25 gram H2SO4. So what will be the molarity of the solution? So molarity will be weight of the solute, that is 25 gram, divided by molecular weight of the solute, that is H2SO4. H2SO4's molecular weight is 98 into 1000 divided by volume of the solution. What is the volume of the solution? That is 100 ml solution. So this is 100. So we can calculate this 250 divided by 98. So it will be close than 2.6. Close then, or 2.5 something. Okay, so we have learned to calculate the molarity. Next we are coming to the normality. N, it is represented as capital N. What is that? Now it is the number of equivalents or number of gram equivalents of solute present in 1 liter solution. Present in 1 liter solution. So how it will be calculated? So normality has the formula of weight of solute or mass of solute in gram divided by equivalent weight of solute. Do you know how to calculate the equivalent weight of the solute? Here solute can be an acid, a base or a salt. So how equivalent weight can be calculated? For acid, equivalent weight can be calculated but as the molecular weight of the acid divided by its basicity. Basicity means the number of H plus ion given by the acid in its aqueous solution, which is called N factor or valency factor. Like H2SO4, it is broken into 2H plus SO4 2 minus. So it gives 2H plus ions in its aqueous solution. So H2SO4 has an N factor of 2 or valency factor of 2. I'll make a different video about calculating equivalent weight. Please watch this. Into 1000 divided by volume of solution. So we can also calculate normality from the above examples. How? I am showing in this. So normality, we have the formula weight of the solute in gram, that is 25 divided by equivalent weight of the solute. I have already said the equivalent weight of H2SO4. How? Its molecular weight divided by its N factor, that is basicity. What is the molecular weight of H2SO4? 98 divided by its basicity. What is the basicity of H2SO4? Which is 2. So 98 by 2, that is 49 equivalent weight into 1000 by volume of the solution. What is the volume of the solution? That is 100 ml. So we can easily calculate its normality. Got it? Very easy. So we can also interconvert between molarity and normality. How? So it has the formula normality equals to molarity into N factor or valency factor. That is, for H2SO4 the N factor or valency factor is 2. We have just learned. So for H2SO4 its normality will be molarity into 2. So its normality will be double of its molarity. Like HCl has an N factor of 1. So it will have normality equals to molarity. Okay, so if you don't know how to calculate equivalent weight, I am saying again, I will make another video for calculation of the equivalent weight. So please watch this. Okay, I am not discussing in this video about the equivalent weight. Next conservation term is molality. Number 3, which is molality. Small m, it is represented by small m. So it has a different definition. So what does that mean? Molality is the number of moles of solute, present or dissolved in 1 kg of solvent. That is, in aqueous solution the solvent is water. So number of moles of solute in 1 kg of solvent. Always remember. So it has a unit of mole per kg solvent. What is the formula? Molality equals to weight of solute or mass of solute in gram divided by molecular weight of solute, which gives the number of moles of the solute, molecular weight of solute into 1000 divided by weight or mass of solvent in gram. Okay, so how we will get weight of solvent? Now weight of solution minus weight of solute. So how will we get weight of the solution, that is volume of solution, and the density of the solution. Volume multiplied by density of the solution, it will give the weight of the solution, and minus weight of the solute, and which is weight of the solute. Let me give an example. Let's take a solution is written as 30% W by V HNO3 solution. 30% W by V. So what does that mean? W by V means in 100 ml solution, that is 30 gram HNO3 is present, and it is also given the density of the solution. The density of the solution is X gram per milliliter. Let's say X. So how will you calculate molality? So we will put the formula of the molality. Weight of the solute, that is 30 gram HNO3, that is 30 divided by molecular weight of the solute. HNO3 has a molecular weight of 63. Okay, so 63 into 1000 divided by weight of the solvent in gram. So we have got 100 ml solution, that is volume of the solution, and we are given the density of the solution. So we will get weight of the solution, that is 100 into X, that is weight of the solution, minus weight of the solute. So what is the weight of the solute? That is 30. This. So this term it will get, or this term will give us the weight of the solvent in gram. So that's how we can calculate molarity of the solution. I hope you understand this. Okay, so let's take the fourth concentration term, which is formality. Formality, and it is represented at capital A. This is a special case. This concentration term is used for the solution of ionic compounds. Ionic compounds have no molecular structure. It has a ionic lattices. It has no molecular existence. So for ionic compounds, their molecular weight term is insignificant. For them, instead of molecular weight, formula weight is been taken. So for ionic compound solution, the molarity term actually is represented as formality. So since they have no molecular structure, so they have no molecular weight term. They have formula weight term. So formality is nothing, just number of formula weights of solute present in 1 liter solution. So how will we calculate formality? Formality equals to weight of solute, similar as molarity, weight of solute in gram divided by formula weight. In molarity, we are taking this as molecular weight. In formality, will be taken as formula weight of solute. And you will be confused that how a formula weight can be calculated. Formula weight can be calculated as same as molecular weight. Like NaCl. NaCl is an ionic compound. So NaCl, we often say that molecular weight of the NaCl, that is sodium 23 plus chlorine 35.5, that is 58.5. And similarly, formula weight of the NaCl will be same. Okay, so no need to worry about formula weight. It is similar or same as molecular weight. Just the term molecular weight will not be used. Instead of molecular weight, we will use formula weight. The calculation process is same. Okay, so formula of the solute N into 100 divided by volume of the solution in milliliter. Okay, so it will be written as F, formal solution, or the solution, its ionic solution of the ionic compounds strength will be written as formality. Got it? Next we have consideration term is the mole fraction, that is fifth, mole fraction. It is represented by chi. This is called chi, chi. It is not x, this is chi. So what is the mole fraction? Mole fraction is number of moles of a component, that is solute or solvent, divided by the total number of moles. So the ratio of the number of moles of a component to the total number of moles. I am giving an example like this. Let's take a solution A and B. A is the solvent and B is the solute. So solvent has a number of moles of Na and solvent, its number of moles is Nb. So we all know how to calculate number of moles. Number of moles equals to the weight, given weight, divided by its molecular weight. Okay, so W by M. This is how the number of moles is being calculated. Weight of the component divided by its molecular weight. So chi of A will be the number of moles. Mole fraction is the number of moles of that component divided by the total number of moles. So whose mole fraction I am going to calculate? A. So mole fraction of A will be the number of moles of A, that is Na, divided by total number of moles. Name means solute and solvent, that is Na plus Nb. And similarly chi of B will be, that means mole fraction of the B will be the number of moles of B, that is Nb, divided by the total number of moles, that is Na plus Nb. So always remember, for a binary solution means a solution which has two components, one solute and one solvent. For a binary solution, their sum of the mole fractions, that is chi A and chi B, will always be 1. This. Okay, so if we know the mole fraction of one component, we will easily can know the mole fraction of the other component, 1 minus that. Okay, so this is mole fraction. Okay, and another similar type concentration term comes, which is called mass fraction. Mass fraction. What is mass fraction? It is similar as mole fraction. Mole fraction means the ratio of the moles, mass fraction means the ratio of the mass. So what is mass fraction? Mass fraction is defined as the ratio of the mass of the component to the total mass. That means mass fraction of any component, mass fraction of any component is equal to the mass of that component, divided by total mass. As for example, let's take this example, solvent A and solvent B. So solvent, let's say solvent has a mass of Wa and solute has a mass of Wb. So what is the mass fraction of A? For A, the mass fraction is mass of A, that means Wa divided by total mass, that is Wa plus Wb. And for B, the mass fraction of B, it will be the mass of B, that is Wb, divided by total mass, Wa plus WB. Got it? Also, for this also the mass fraction of A and B will be equals to the 1. So mass fraction of A plus B will be equals to the 1, just like mole fraction. Okay, and last, this is ppm. It calls parts per million. Parts per million. Million means 10 lakhs. So it is defined as the mass of the solute present per millionth of the mass of the solution or mass of the solvent. So per million mass solution or in solvent, the amount, the mass of solute present in it. So it is mainly used to measure the hardness of water. So how ppm is calculated? ppm means mass of solute divided by mass of solvent into 10 to the power 6. 10 to the power 6 means 10 lakhs or 1 million, or it can be written as mass of solute divided by mass of solution into 10 to the power 6. Now we learn about the relation between molality and molarity. Molality and molarity, that is small m and capital M. So let's take a solution. Let's take a solution whose molarity is capital M and molality is small m, and the density of the solution is small d. Okay, so we can establish this, but just remember the formula. Molality equals to 1000 into molarity divided by 1000 into density of the solution minus molarity into molecular mass of the solute. So small m equals to 1000 into capital M divided by 1000 into density minus molarity into molecular mass of the solute. So now we will come into the relation between molality and mole fraction for non-aqueous solution. Molality and mole fraction, and this is for non-aqueous solution. Non-aqueous. Okay, so what is the relation? Molality equals to mole fraction of solute. It can also be established, so I suggest you remember this. Mole fraction of solute divided by mole fraction of solvent into 1000 divided by molecular weight of solvent. So if you are given as the mole fraction of solute, so we can easily calculate the mole fraction of solvent. 1 minus that. Suppose the mole fraction of solute is given as 0.2. So mole fraction of the solvent will be 1 minus 0.2, that is 0.8. We can easily calculate and put for non-aqueous solvents. But for aqueous solution, it is far more easier to remember. For aqueous solution, when solvent is water, that is molality divided by molality plus 55.56 equals to mole fraction of solute equals to mole fraction of solute. So from this relation we can calculate mole fraction of the solute or molality of the solution. If you are given as the molecular mole fraction of solvent, so solute mole fraction will be 1 minus mole fraction of the solvent. So we can easily put into this equation and calculate whether which one is asked, mole fraction of solute or molarity of the solution or mole fraction of the solvent. Okay, so that's the relation. Okay.